Hi everybody, it's Mrs. Peachy again, and we are going to continue with our review for the semester 2 test for physical science. Okay, so we talked a little bit about momentum, that momentum is mass times velocity, but it really has to do with collisions between objects. I mean, an object has momentum, but what we really are interested in is exchanges or changes in momentum, but then the whole system remaining constant. So essentially, if two objects collide, their individual momentums can change, but the total momentum of the system, let me just move this box down a little bit for you. Remains constant. Okay, this is called the conservation of momentum law, and it kind of goes along with conservation of mass, conservation of energy. They're all conserved, right? When it comes to, well, the next thing we talked about is electricity, static, and moving or current electricity. So first we looked at, well, hang on, before we get there, I want to talk about different kinds of forces. Okay, so forces, remember, a force is a push or pull. So we have different forces. We have electric forces, which sometimes we call electrostatic, or we even call them electromagnetic. Okay, so this is where two, well, hang on. So oppositely charged particles are going to repel and are going to attract, and likely charged particles are going to repel, right? This is the same thing that's true in magnets too. So this is why we call it electromagnetic, because it's true with both charged particles and with magnetic particles, or magnets, I should say. We have gravitational force, right? We have strong and weak nuclear forces. So for example, the strong nuclear force is what holds the nucleus of an atom together, and the weak nuclear force is what holds the electrons to the atom, kind of the electron and protons being attracted to one another. And then we have, we have applied forces. So those are forces that we can apply to things, or that a boulder rolling down a hill applies to your car or whatever. They're forces that are, we have the normal force, which is basically the upward force that is opposite of the gravitational force, or the weight of an object. So an object is sitting on the ground and pushing down on the ground, and the normal force pushes up with an equal and opposite magnitude. Okay. So then we looked at fluids. Okay. And we looked at, for example, where when you're looking at water, it gets higher pressure as you go down. We looked at buoyant force. So the buoyant force is the upward push. And it is equal to the weight of the fluid displaced by the object. Okay, and then let's see here. We looked at work. Work was another concept that was covered in this semester. Work is force times distance, and it's measured in newtons. Actually, it's measured in Newton meters, which is a joule, I'm sorry. So a joule is equal to a Newton meter. And it's essentially the ability, so it's moving a force over a distance, and energy is the ability to do work. So they're really closely related. Energy is also measured in Newton, or in Newton meters and joules there. We looked at mechanical advantage in simple machines. Mechanical advantage, which has no units, it is when you take the output force and divide it by the input force. Basically, it's like if I want to lift something heavy and I can't lift it because I'm not strong enough, if I use a lever and put it underneath of it, I can apply less force and I can move that object. But the lever moves quite a bit. I have to push down on the lever quite a bit to move the rock or whatever it is just a little bit. So you're compromising distance. So you can move a heavier force, but you have to move it a smaller distance. So that's how many of our different simple machines work. Okay. Sometimes it can be the other way around. Sometimes you can move something a great distance, but you're using, you actually have to move more force. And that's not very often, but that does occur if you want to move something very far. But you have to push it or, apply a greater input force. That's also a potential. Types of simple machines would be things like a screw, a lever, block and tackle or a pulley, wheel and axle, a ramp or an inclined plane they call it, a wedge. So I think those are all of them. Okay. So then we looked at energy, right? Because remember, energy is just the ability to do work. Energy is the ability to do work, and it's measured in joules also, right? We looked at kind of just two main types of energy, potential energy and kinetic energy, and they're both types of gravitational energy, okay? So potential energy is due to the height of something above the earth. If you think about it this way, the farther something falls, the greater the force it's going to have when it hits the ground, right? So the greater the ability to do work, because force is, or work is force times distance. So if it, like, you drop something and it lands, say, on a lever and launches something else into the air, the harder you do that, the quicker the lever moves and the higher the object is launched into the air so it can do more work, okay? That kind of gives you an idea. Think of a Wile E. Coyote and the Roadrunner or something like that. So potential energy is measured as mass times, I don't want that, mass times the gravitational acceleration, 9.81 meters per second squared, times the height of it above the Earth. And that is the potential energy, and it is in joules, okay? Kinetic energy is energy of motion. So potential energy is the ability of something to do work. It's like potential. It's not happening yet, but it has this potential. Kinetic energy is due to the object's motion. The faster an object is moving, the more kinetic energy it's going to have. So it's going to hit something harder, and there it's going to do the same thing, apply a greater force. So kinetic energy is equal to 1/2 of the mass of the object times the velocity of the object squared. And that's going to be equal to kinetic energy also measured in joules. So potential energy is not affected by the speed because the object's not in motion, remember. It's not moving yet, it's only has the potential to move, and therefore, if it does start to move, we'll start seeing kinetic energy at that point. Kinetic energy and potential energy are related to one another, right? Because the kinetic energy plus the potential energy is equal to the total energy of the system, and it should be the same. Total energy never changes, okay? So total energy does not change. It can be transferred to a different type of energy, to heat or to transfer it to be able to deform something when it breaks it, but that stays the same. So as potential energy goes down as the object is falling, kinetic energy goes up because it speeds up, right? Let's see where we are. So energy comes from many different places. Renewable energy is from the sun mostly. Okay, so when we think of all kinds of renewable energy, whether it's solar or wind or tidal, all those types of renewable energy are affected by the sun. The sun is producing heat. The heat is, or the light is a type of energy in and of itself. It can also create different pressures of air, which then move from an area of high pressure to low pressure. And that's what wind is. And so wind is caused by the sun. And even the tides are influenced by the sun, and the moon as well. So those things are kind of influenced by the sun. You do have other things like geothermal energy, which comes from inside the earth, which is not influenced by the sun at all. But most renewable energy types originate from the sun. All right, we're almost out of time on this part of the test review as well, so we're going to be probably into at least 2 or at least 3 parts here. So if you want to go on to part 3 after this, and hopefully I think that'll be the last part of the final exam review for physical science.